Okay class, this video is on the Chatelier's principle. There's going to be a quiz on Wednesday, which is half day, so I figured this is the best time to review. So very first factor, we have temperature. So in an equation it would be labeled as energy. So we're saying if we increase the temperature on this side, on the right hand side, we're going to see a shift in the direction that decreases the energy. So it's going to try to offload the energy onto the other side. So we decrease this, we're going to see a change pushing it to the other side, because there's an excess of energy on this side, so it's going to try to offload it onto the other side. If we increase the temperature, we'll see on the reactant side, it'll shift to the product side. Okay, so this is the same thing as the last slide, it's just energy or temperature is on the other side of the equation. If we decrease the temperature, we're going to see equilibrium shift to where the energy was lost. So energy was lost over here on the reactant side. We're going to see a shift that tries to bring energy back. So what it's saying is, if this product breaks down into A and B, there's going to be a release of energy also. So we're going to gain that energy that we just lost. If we add a reactant or product, it shifts the reaction in the direction that removes them. Okay, so if we increase concentration of A, we're going to see a forward push towards products. If we increase C, we're going to see a push towards the reactants. Now, I'd say even for the quiz, if you don't understand all of these concepts, it's fine. Just take in this small little cheat right here. If you see an arrow going up, that means it's going to push it to the opposite side. So let's say I put the arrow up on the reactant side. Then we're going to see a change on the opposite side. So then the arrow that's going to follow is going to go this way. Okay? If I had, let me change the color here. If I had an increase on this side, so on the side of the products, then the change is going to be on the opposite side. So we're going to see a change going there. What if I had a decrease? Now a decrease brings something to the same side. So if I have a decrease on the side of the reactants, we're going to see equilibrium bring the arrow towards the side where there was a decrease. Okay? So hopefully that's a little cheat that'll help you. So going up goes to the opposite side, and going down brings it to the same side. Generally this rule will work for you. So here we decrease concentration of A, so then we see arrows here on the side of the reactants. If you follow this little cheat right here, the arrow is going to shift to the same side. So we're going to see equilibrium shift to the side of the reactants. If we remove product, we're going to see a shift on the same side. Okay. Only changes to aqueous and gas states can cause equilibrium to shift. Solid and liquid do not, because they're not concentrations. You can't actually modify them. So in this case, changing calcium carbonate is not going to do anything, and changing water is not going to do anything either. The rest of them, however, they will shift equilibrium if you stress one of them. So no shift, shifts to the right. This is on the same side, so this is going down, so we're going to see a shift on the same side, so it's going to shift to the left. This one right here is up to the left because it's on the opposite side. If we decrease Cl2 over here, we'll see a shift on the right hand side because the arrows will come to the same side. And Cl2, if we increase it, is going to push to the opposite side, so it's going to go left. And once again, because water is liquid, there's going to be no shift regardless of what you change. Important point to note, catalyst does not shift equilibrium. It's just that the rates are increased by the same amount, so you just attain equilibrium faster. So if I mixed my reactants A and B, and it took me, let's say, 5 minutes to reach equilibrium. If I add A and B plus a catalyst, then we could say I reach equilibrium in perhaps 3 minutes. So the reaction goes faster. The same point, equilibrium is just achieved faster, but nothing else changes. The position of equilibrium, so the amount of the concentration of reactants and the concentration of products you have at equilibrium will not change at all. They will just be attained faster. Adding an inert gas such as argon or xenon is not going to shift equilibrium. So if you add neon to either side, it doesn't do anything. Okay, so here's a bit of review. So if you add CO, okay, so we're increasing the concentration of CO. Where are we going to see the shift? Now remember that sheet that I gave you. If the arrow is going up, we're going to see a shift on the opposite side. So our guess is going to go to the right hand side. So we increase CO here, and there we go. We get a push to the right hand side. So forward rate increases, and you won't see a change in the reverse rate. What if we remove CO2? I'm sorry, CO. So we remove carbon monoxide. Then remember that sheet. The arrow is going to bring it to the same side where the shift occurred, or sorry, where the change occurred. So our guess is going to move left. So here we decrease CO, and we see a shift to the left. So what if we increase temperature here? So the arrow is going up, that means shift will be on the opposite side, so it's going to go left. And there we go. Now both forward and reverse rates, they increase because we have extra energy in the system. We've increased the temperature. So naturally the rates are just going to be faster. And because equilibrium is pushing it to the left, our reverse rate, so the one that's going left, is going to increase more. Hopefully that is good enough review for you guys. Good luck on the quiz. You're going to have to think about temperature, pressure, adding inert gases, increasing or decreasing temperature. There's not much else. Just remember the relationship between volume and pressure. So it's inversely related. If you increase volume, you decrease pressure, and vice versa. Right? Good luck.